In section 3.4 we're working with sum and difference formulas, and with these formulas we'll be able to find exact values and establish identities. And what we have is, if you have an odd angle, like let's say you're working with an angle of 105 degrees and it's not on the unit circle, what we can do is we can either add or subtract some values that are on the unit circle to be able to find these values. Here's a little closer look at these formulas. We have the sum of two angles for cosine, and then the difference of two angles for cosine. Then we have the sum and difference formula for sine. And then we have the sum and difference formula for tangent. Okay, so for this example we have the cosine of 105 degrees, which is not on the unit circle. However, 60 and 45 are on the unit circle, and they add up to 105. Now for cosine, our sum of two angles formula, we're going to take those two angles, 60 and 45, then we have the cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. So now when we're solving this, now we just use our unit circle and we can find those values. We know that the cosine of 60, for example, is 1/2. And the cosine of 45 is square root of 2 over 2. So we're going to multiply those two values. And then we also know that the sine of 60 is square root of 3 over 2. And the sine of 45 is square root of 2 over 2. And we're going to multiply those two values. So here we end up with square root of 2 over 4 minus square root of 6 over 4. We have our common denominator here, so we can subtract those values. Our exact answer is square root of 2 minus the square root of 6 all over 4. For this example, we'll again use the angle 105. Now we're taking the sine of 105 degrees. Only this time we're going to take the difference. So it really doesn't make a difference which formula we use, as long as we're getting to this point. We could have done this with our cosine example too. Would have been a little different on this side because it's a slightly different formula, but we would have ended up back in the same spot. Now here we're taking the sine of 105, so we're going to take the sine of 150 minus 45. Both of those values again are on our unit circle. So then our sine, our difference of two angles for our sine formula, we're going to take the sine of 150 times the cosine of 45 minus the cosine of 150 times the sine of 45. Again, we want to find these values on the unit circle. We know that the sine of 150 is 1/2, and the cosine of 45 square root of 2 over 2. And the cosine of 150 is negative square root of 3 over 2, and the sine of 45 is square root of 2 over 2. Now we go ahead and multiply these values. Again, we have square root of 2 over 4 here, multiply here, and we end up with a negative square root of 6 over 4, and we're subtracting these. So now we end up with square root of 2 minus the negative goes, I wrote that wrong, square root of 2 plus square root of 6 all over 4. For this example, we're taking the tangent of 7 pi over 12. Again, this angle is not on the unit circle. However, 3 pi over 12 plus 4 pi over 12 is equal to that angle, and that would be the same as pi over 4 plus pi over 3. So if we take the tangent of this angle, that's the tangent of these two angles. Our formula for the sum of two angles, then, we're looking at the tangent of pi over 4 plus the tangent of pi over 3 all over 1 minus the tangent of pi over 4 times the tangent of pi over 3. Now from here, we know our tangent of pi over 4 is equal to 1, and the tangent of pi over 3 is equal to the square root of 3. That's 1 minus 1 times square root of 3. So we'll multiply here. We end up with 1 plus square root of 3 over 1 minus square root of 3. To rationalize the denominator, we'll multiply by 1 plus the square root of 3 on top and bottom. So here we end up with difference of squares, so we have 1 squared and square root of 3 squared, so 1 minus 3 for our denominator, and then we have 1 plus square root of 3 squared on the top of our fraction. We can go ahead and FOIL this. That's going to be 1 plus 2 square root 3 plus 3 all over 1 minus 3, which is negative 2. Now we have the 1 plus 3 gives us a 4 plus 2 square root 3 all over our negative 2, and we can divide each of those values now by negative 2. So we have a negative 2 minus square root of 3. That would be our exact answer. In this problem, we're going to find the exact value of sine of alpha plus beta. And here we're given that the cosine of alpha is equal to square root of 5 over 5, and the sine of beta is equal to negative 4/5. Here we're told that alpha is in between 0 and pi over 2. Here we're told beta is in between negative pi over 2 and 0. So what we have is first quadrant, fourth quadrant, and what we want to do is draw ourselves a couple of triangles. So I have a triangle here in the first quadrant. So here's alpha, and its cosine is square root of 5 over 5. So that's going to make this side, that's our adjacent is square root of 5, and our hypotenuse is 5. And then here we have sine of beta in the fourth quadrant, so now that's our right triangle. That's giving us beta is this angle, and opposite is negative 4, hypotenuse is 5. So now we can use Pythagorean theorem to find the other sides of our triangles. This would be 3, and here we would be at 2 square root 5. Now that we have our two triangles, and I drew them differently because this one's in quadrant 1 and this one's in quadrant 4. So we want to make sure and draw them appropriately so we can pay attention to our positive and negative sides. And now we're going to go through with our sum formula for sine of alpha plus beta. And we know that formula is the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And now we just use each of these triangles to plug in these values. So whenever we're talking about alpha, then we're going to use this first triangle. And whenever we're looking at beta, then we're using the second triangle. So here we have our sine of alpha, which is opposite over hypotenuse. So that's going to be 2 square root 5 over 5 times the cosine of beta. Beta is here, adjacent over hypotenuse, gives us 3 over 5. Plus cosine of alpha. Alpha is in this triangle. Cosine is adjacent over hypotenuse. That is our square root of 5 over 5. Times the sine of beta, opposite over hypotenuse. That's our negative 4 over 5. And now we multiply those values. So 2 square root of 5 times 3 gives us 6 square root of 5 all over 25. Plus square root of 5 times the negative 4 gives us negative 4 square root 5 all over 25. Now we combine like terms. 6 square root 5 minus 4 square root 5 is 2 square root 5 all over 25. And that would be our exact answer.